All right, welcome everyone to our last session for the day. I do promise this is the best session. So today we're going to have a session on from text to taxonomy, how the Australian government is revolutionising data classification with ML. This is a level 200 session. Just before I welcome our speakers, if we could all just make sure our phones are silenced as a courtesy to all of our other audience members, and just if we haven't already, if we could download the AWS Summit app, that would be great, just so we can provide feedback to our speakers. Now, without further ado, I'd like to welcome to the stage Kane Hopwood.
Thanks, Mahek. Hi, my name is Kane. I'm a solutions architect working in the federal team for public sector. I'm also an AI/ML specialist, and I've been a software engineer for probably longer than I'd care to admit. Now, you guys have used forms. We all use forms every day. The reason you're sitting here today is because you filled out a form. That form was the Summit registration form. And on forms like that, there is typically a field called, what job you do or what organization you work for. And the reason that exists in the case of Summit is so that you can, so the Summit organizers can plan future events. We didn't have a public sector track at the last Summit, and this is the first time we've had one, thanks to you and the fields you've put on that form. Now, a good way to implement a field like that is with free text. It gives you the opportunity to put in whatever your particular job is. It's most inclusive, but it presents a problem for the poor engineer who is implementing that form, because the Summit organisers want to have everyone sorted into 10 or 15 different categories. So how does the engineer take all the free text and categorise it accordingly? So us engineers, we have a tried and true mechanism for solving that particular problem, and that solution is we make the user do the work. So that our intrepid engineer changes the free text to a drop-down, populates the drop-down with what's on the with the Summit organisers list. Job done, off to the pub for lunch. Of course, you and I will know this just creates another problem, and that problem is like, what do people do who don't fit the categorization? Or what if they fit multiple categorizations? Like, I work for Amazon. Do I put myself down as a software company? Do I put myself down as a IT and networking company? Or we've got Kuiper satellites up in orbit now, so I could do aerospace if I wanted to have a lark, right? So this results in an issue where the data is not very good. So maybe 10 or 15% of the fields are just badly, don't represent reality. Now, for Summit, that's probably okay. There's still enough information there for everyone to plan. But there is an organisation for which 10 or 15% is not an acceptable level of error. And that organisation is called the Australian Bureau of Statistics. In fact, for some applications at the ABS, like 0.1% error is not acceptable. So the ABS typically will not use the easy drop-down option, and they will use free text on their fields when they can. So how do they solve the mapping problem? And how do they solve it for not thousands of responses and a handful of categories, but like millions or tens of millions of responses and thousands of categories? Well, to answer that, I'd like to invite Aidan and Sterling from the ABS to the stage to go through the details of exactly why they made their changes and exactly how they made those changes. Thank you.
Thanks, Kane. Howdy, everyone. When you're at home and you turn on the light switch or you turn on the tap, I think the idea of, you see the water, you see the light, but you don't really see the pipes or the cables that connect and enable that, or the standards that make sure that the voltage is correct or that the water's drinkable. And it's really the same for official statistics. The sort of infrastructure that is unseen but essential, that allows official statistics to be produced and be of quality. These infrastructure are unseen. The ABS recently updated one of those bits of infrastructure and produced an updated and comprehensive new classification standard for our occupation. But we know there's a pain point in having that adopted widely with users, that if they're not supported, they can adopt it inconsistently or even sometimes not at all. And we also know that legacy coding that supports the application of the classification can result in significant volumes of manual coding. And the idea of, that's just not really acceptable now with today's data volumes, and it's quite effortful. So that's a problem for users. So the ABS really foresaw an opportunity to use AI and enhance our existing application of machine learning to solve this problem for users. And the way we've realized that is with a technology stack powered by AWS and AWS support. Things like Jupyter Notebooks through to SageMaker AI. I think the really great thing from that is we now have a powerful environment in which we can securely train models. And also we can make that through API available across government, which is really wonderful. So in terms of the training of the models, it's really important that for the ABS that we do this in a way that's transparent and traceable. We want to make sure that we have data that is of high quality and also builds confidence in the service. One of the great things about having the ABS is that we have a data set that allows us to train models that are really reflective of the broad language and the common terms that Australians actually use when they're describing their jobs. So whether the service sees something like an electrician or a Sparky, the service knows what that occupation is and can code it appropriately. Look, the other angle is that we've got a space that's really powerful and dynamic and allows us to do this today, but also potentially explore and leverage machine learning opportunities as they emerge over time. With regards to the outcomes that we're seeing from testing, we're actually really excited by what we've seen internally. A highly performant model that is going to reduce our manual coding and increase our auto coding. But also from our testing partners, we're learning that the service that we're offering, it's going to enable them to adopt this new classification. Previously, that adoption was something that may have been burdensome or potentially compliance driven, and now shifting that to something that is going to be a genuine value add for them. It supports them consistently apply the application, which increases their data quality, but it also saves them time and effort. So overall, what we're hoping will happen is that as the classification is increasingly adopted through the use of the service, that Australia's data landscape around occupation will improve and increasingly become coherent. Sterling's going to talk over the next 20 minutes to the work that we've done, and I think the architecture that we've had that allows us to have text taxonomy capability, what that might mean for the ABS, but also some of the lessons that we've learned along the way. And I guess in terms of following the themes from the last couple of days that we've had here, our hope was that for you, whether you're a builder looking to integrate machine learning or an innovator looking to potentially unlock data, that we have something in our talk today for you to take away. Thank you all. Over to you, Sterling.
Thanks, mate. Cheers. Thanks, Aidan. And can everyone hear me? If you can hear me, just raise your hand. And the other one, wave them around. Thanks. Just wanted to actually see how many people would do that. So my name is Sterling. My nominal position, or my current position in the ABS, is as the product owner of the ABS's whole of Australian government coding capability project. My nominal role within the ABS is actually within the statistical standards and infrastructure section, where I lead a team of people who maintain a range of data coding technologies and tools that are used broadly across the ABS for the production of official statistics. You might be sitting out there thinking, Actually, coding and data coding, that might mean something completely different to me. So for the context of this presentation and within the ABS, data coding is the process of taking survey and admin data textual responses and transforming those into an ABS structured classification code so that we can produce coherent and comparable official statistics. And what does that look like in practice? And on the screen you can see we've got a census form, whether it's online or via paper. And in this particular instance, we're asking about the person's occupation. The first question, in the main job held last week, what was the person's occupation? And in the response, what we've got here is a lawyer's assistant. The second question, what are the main tasks that the person usually performs in that occupation? And their response there is admin tasks for lawyers. Now our data coding tool takes just those textual responses, so no personal information, no census reference information, just the text, passes that through our data coding tool and produces an occupation classified code. Now, you see here on the screen that it talks about Oscar. Oscar is our new occupation standard classification for Australia 2024, released late last year. So in this case, we've generated, as you can see on the screen, we've generated a code 5212 legal secretary. That code is then written back to our data store and updated for the production and the rest of the statistical production cycle. You might note that the actual code that's associated there and the title is legal secretary, which is quite different to what the person's actually put on the form. And that speaks to the real value of this product, allowing the Australian population to answer the form in a language and a vocabulary that makes sense to them. Then we take the task of turning that into our structured classification code so that we can produce comparable statistics. If we look around the room, I think a lot of you, if you were asked what your occupation was, is going to be pretty similar. I'm taking an assumption here that there's a lot of people here that do very similar tasks. But if I asked you to write that down, what you do, almost everyone's going to write something a little bit different. And that's what the power and the real genius of this is. So on the screen here is one example of how the Census 2026 team will be able to use a range of machine learning models to produce a high auto-coding rate to the highest possible quality. And those are the two drivers for us, is auto-coding rates, which reduce clerical coding effort, and quality, ensuring that the quality that we're producing is fit for purpose. Now, walking through that, the occupation, this is an occupation example, and these numbers on the screen are numbers that we've generated from our testing to date, which has been extensive, and we're confident that we will hit these targets or even better. So we know that about 9 to 10% of our responses for occupation are coded at the point of data capture. And that is, we use targeted supplementary questions for some of the more straightforward occupations, and we can code it right there at the point of capture. The remaining 90% are passed through to our first HSVM trained machine learning autocoder. And we know from our testing that we can code about 90% of those records, leaving us in a position where we've got 90% of records coded. We then pass what hasn't coded, the remaining 10%, to a large language trained model, which we know can code a little bit higher numbers than the HSVM models, getting us to about 93%. And then we would also, at this point, we'd identify that using the occupation responses, we've auto-coded about what we can, given the available quality of those responses. But we can also factor in some of the industry responses that may help us to get that extra 2% to get us to 95% coding quality, leaving us with about 5% of records that need clerical or manual review. Now, so looking at our previous census, in 2021, getting to 95% auto-coding for occupation is a 20% reduction. And ladies and gentlemen, 20% at census scale, we're talking millions of records, we're talking hundreds of people, and months worth of effort to get to the same point. But the real value isn't necessarily in the efficiencies and the savings that could potentially generate, it's in the time. We now have the opportunity to focus those efforts on quality and ensuring that the ML-coded data set is as a higher quality possible. which of course is critical when we look to the future and we're starting to train new models on that same data. But if you'll indulge me, I just want to take you on a little journey back through time. Back to 1970, computers were brand new. They were the size of a room, they could only do basic computational mathematical equations. Jumping forward 10 years' time to 1980s, and all of a sudden computers are much more common. They're in households, they're in businesses, they're in our schools. We're walking around with 4-inch floppy disks with 1.4 megabytes worth of information in them. And you know, in there we've got our documents, we've got our save games, our Carmen Sandiego progress. Speaking to my childhood there. But in the same period in 1980, the ABS started using computers for processing survey responses. And what that looked like was reviewing our previous responses, creating an index of the code, and then every time we saw that response in the subsequent surveys, we would apply that same code. It was fairly rudimentary. Stepping forward again to 1990, and we see the introduction of compact disks, little shiny round thing that used to blind you in the sun. But they could store 750 megabytes worth of data. It's 500 floppy disks, a revolution by scale. Let's step forward even further to 2020. Our classifications have grown drastically more complex. The occupation classification, in fact, the new Oscar classification, has over 1,300 codes of different occupations listed in it. The index that sits behind that has over 60,000 lines of potential response text mapped to a code. I can tell you firsthand, it's a mammoth effort to update that index. And every time we update the classification, or every time there's a change in the way people refer to their occupation, or new occupations emerge, we have to update that index. It's a mammoth task. But technology has changed substantially. And surely there's a better way of doing this than using index technology we developed in 1980. Well, it turns out there is. So for the past 10 years, the ABS methodology team, in conjunction with our technology services area, have developed a machine learning-based auto-coding solution using support vector machines that we affectionately called the ABS Intelligent Coder. This product demonstrated the real value and potential uplift of using machine learning to perform this data coding process, and the efficiencies that we can gain in not having to maintain these complex indexes and training models on data that we've already got available to us in our previous census data. However, the ABS Intelligent Coder was developed with on-prem technology. It was limited. We could only train models with about 600,000 records, and it would take a week to train a model. That drastically inhibits what we could potentially do with this technology. So we launched into a proof of concept program with an organization called Max Kelsen, a partner agency with AWS. And through that proof of concept, Max Kelsen helped us to create the design for an infrastructure and architecture that would allow us to build machine learning models using AWS's MLOps cloud-based solution, using cloud-based technologies. And at the same time, they explored the use of large language models, recognizing at the time, whilst we have 10 years worth of experience with support vector machines, that technology in itself has changed, and large language models are now the rage. So we need to understand what is the best solution for our particular use case. Enter the whole of Australian Government Coding Capability Project. I'm happy to report that we've been able to productionize those designs. We have the cloud infrastructure in place, we have SageMaker pipelines, we have notebooks, and we've already begun training those models. Our project has a clear goal and a clear scope, which are really important. To embrace machine learning, to accurately and efficiently code textual data to ABS structured classifications, that's our goal, and our scope is to deliver an AWS cloud-based machine learning, a multi-machine learning method, data coding capability for the 2026 census, and that's capable of being served to the whole of Australian government via secure and performant external API service. Presented on the screen is an example of the infrastructure that we've put together. we've created 3 dedicated ABS-owned AWS accounts that are all within Australian shores. One particular account is used for training and model refinement and as a data store for our census training data. Then we have a dedicated internal account for internal areas via, again, an authenticated API service to access the trained models once they're deployed. And we have a dedicated external service, which is what we're going to use to allow external users to access the same models that we use inside the ABS for their own use outside when they're coding and collecting data for the same topics. So our MLOps solution looks a bit like this. We've got a range of different SageMaker pipelines that we're using to train different topics. We have the ability to set machine learning parameters for each of those topics, because they're all slightly different and there's a bit of exploration for each particular topic. Once the model is successfully trained, it's produced and promoted to our model registry. And from the model registry, we can review high-level machine learning metrics, and we have the ability to approve and deploy that model to those inference accounts. We also have a range of Amazon Jupyter notebooks that are used for doing more granular refinement of those models. The machine learning metrics provide a good guide for how well it's learnt, but they don't tell us how well that model is going to be able to code to each of the different levels in those classification structure. So we use our notebooks to do testing of the model to ensure that it's doing exactly what we want it to do at the granular level before we go through and deploy it for use. So one of the key things about training a machine learning model is ensuring that the data that you're using to train that model is fit for use and it's of high quality. What do we do when we've trained a model, but we've identified that there are certain areas of the classification that aren't coding well? Well, at that point, we need to go back and have a look at the training data and understand why. That's a huge task when you're talking about millions of records. So we developed a confident learning solution. The confident learning solution is supported by an AWS SageMaker pipeline in itself, which creates a data set, a larger data set that is then accessed via a custom UI that we built in-house. It provides model developers with the ability to do targeted training data review. They can search and they can filter. It produces a machine learning confidence-based score. It suggests alternative codes using its own machine learning generator. And it tracks the changes, which provides lineage of data changes over time. It then exports the data and we can then move in and retrain a model and start our tests again in an iterative process. One of the big uplifts that we've got through our MLOps solution is the ability to use varying machine learning methods. And as you can see, our 2 primary methods that we're using are a HSVM hierarchical support vector machine. And for those that might be new, even though it's old technology, that is us training a model on a pre-coded data set or a curated data set that we already have. We also have the ability to train large language models, where we take that same data set, but add the advantage of a Dilbert large language library to expand the vocabulary and connections, drastically increasing the capability of that model. And an important thing, which I'll talk about again later, is that we've developed this solution with the ability to adapt to new methods as they emerge into the future. Even in the time that we've created this product, there are already new opportunities and new machine learning methods that we can start to look at and explore. So we developed our product, not limited to what we've had, but rather what we could potentially do in the future. So the question you're probably asking is, why HSVM first? What's the difference? And there are a range of benefits and disbenefits to HSVMs and large language models for our specific business case. Both methods are simple and fast to train. We can train a 10 million record HSVM or large language model in the matter of an hour. They're both highly performant at the task of coding. In fact, a large language model can probably code a few % more than the HSVM can, because it has that expanded vocabulary. The HSVM tends to be more accurate at coding shorter text, which is more similar to what we expect to see from a survey response, whereas the large language model is better at deciphering longer sentence structures, more text, and can even decipher effectively the meaning of that sentence structure. The hierarchical support vector machine allows us to code to a full classification structure. If a response is more vague or isn't vague enough to land on a 5-digit lowest level occupation, it can code to a higher level of the classification structure, and that's an important element for us. Whereas a large language model, the way we've developed it, is limited to only the lowest level of the classification. HSVMs are typically smaller than a large language model, therefore the lower consumption effort, lower computational effort and lower cost, but it's all comparable. But most importantly, and this is the key thing for us, is the ability to explain what the model is doing, and that's why we put a lot of weight in the HSVM method. The HSVM is trained on data that we control, using algorithms that we've created and that we understand and can unpack quickly. The large language model uses a language and a library that is outside of our control, using neural networks that are near on impossible to unpack. And that's a problem when we're producing official statistics that people want to challenge. So how do we know which method is right for our service and for what we're doing? Well, this was a bit contested in the ABS because those range of benefits and disbenefits, some people prefer one method over the other. So we needed a construct to help us make that decision and to actually be able to structure. So we created a model suitability framework. So the model suitability framework recognizes that model performance is not the only consideration, but the business case and those additional factors need to be brought into the decision-making process. And you will notice that in this structure, the thing on top is the business needs. It's really important to specify what your business needs up front before you go down the path of deciding on a particular method or approach. There's a range of questions that you should ask yourself when you're in this process. Some of the ones that we asked were, does this require hierarchical coding? Only one of our solutions supports that. Does this require coding transparency? Do we need the ability to unpack and understand why the code has made certain decisions? Are there cost and time constraints? And is there an appetite for clerical coding? Which we know one of the main objectives for Census is to reduce the clerical coding effort and maintain and improve on the data quality. So the Census solution looks a little like this. We've got the models are produced to our ABS internal account, accessed through an API, an authenticated API. The data comes in from the census form, flows through the models, and is written back to the data store. The data that can't be coded goes to our manual coding team, and then once complete, the data moves to our data quality team. The data quality team then focus their energy on ensuring that the data is fit for production, that is of high quality. They can also recode the entire data set in a matter of minutes using our AWS solution. What does that mean for you? We've actually made it, as I mentioned earlier, our whole of Australian government coding capability allows for the addition of a dedicated external secure account accessible via an authenticated API and allowing access to our 2 occupation models, ANSCO 2022, our previous occupation classification, and OSCA 2024, the current occupation classification. We have 2 services that people can register for. We have a partnered service and a public service. The public service supports single record coding with a 1-second response time, so you can integrate into your websites or your own data capture systems. And the partner service supports the ability to upload large files and code batch files of millions of records and return a file that's completely coded. Now, our solutions are IRAP assessed and certified and compliant with the policy for responsible use of AI in government. Very quickly, on the topic of upskilling, this is a complex project. Don't kid yourself that this is simple or an easy task. This has taken a great deal of effort across multidisciplinary teams in the ABS, and it's required an agile approach to learning from all fronts. What we thought we knew 2 years ago may not necessarily be true today, and what we know today may not necessarily be true later. So we need to adapt and move with the project as it moves, focusing on our key goal and objective all the way through. So some quick lessons learned in the last 30 seconds. Thinking forward and designing your solutions for the future. Don't build for what you needed yesterday, build for what you could potentially do tomorrow. Ensure that your training data is fit for purpose. Your model is only ever going to be as good as the data you're training it on. True collaboration is critical, and everyone needs to work to a common goal. And the last thing is clearly define business needs, and you may require your own construct that supports deciding on what the right method and model is for you. Thank you very much.
Can we keep